Okay, so we are working through the questions in the discriminant part of your notes. We're working through 1 to 9, and this is question 6. So here we go. Find the set of values of k for which the equation this has real roots. So immediately what might throw us off is the fact that it doesn't tell us whether these roots are repeated or whether they are distinct. If they are repeated roots, that's going to mean that my discriminant is going to be equal to 0. But they could also be distinct roots, and if they are distinct roots, that's going to mean that my discriminant is greater than 0. So because they don't specify this, what I'm going to have to say is that my discriminant could be greater than or equal to 0. From here, what I'm going to do is write b squared minus 4ac is greater than or equal to 0. And now I'm going to have to identify my a, b, and c values. So my a value will be 1 plus 2k, 1 plus 2k. My b value, so that's my a value, my b value will be negative 10, and my c value will be k minus 2, k minus 2. I now am going to sub these values into my discriminant. So I'm going to be left with b squared is going to be negative 10 squared, which will be 100, minus 4 times 1 plus 2k, 1 plus 2k, times k minus 2, k minus 2, and all of this will be greater than or equal to 0. Then I'm going to go 100 minus 4, and I'm going to expand out these brackets, and by expanding them out, I'm going to be left with 2k squared minus 3k minus 2 is greater than or equal to 0. I then am going to expand out that bracket by timesing everything by negative 4, so I'm going to be left with 100 minus 8k squared plus 12k plus 8 is greater than or equal to 0. Then I'm going to gather my constants here. I have 8 and 100, and I'm going to rearrange it as well. So I have my leading term as my squared plus 12k plus 108 is greater than or equal to 0. I don't like it when I have a negative as my leading term, so I'm going to divide both sides by negative 1 and going to be left with 8k squared minus 12k minus 108, and because I'm dividing across by a negative, I'm going to have to swap over my inequality. So here we go. I also noticed that I could divide everything here by 4. If I divide this by 4, I'm going to get 2k squared minus 3k minus 27 is greater than or equal to 0. Okay, let me just highlight this because this is important. All right, let's just take a breather. We've gotten this far. I have to solve for k. That's the reason why we're here. So what I'm going to have to do, so let me just kind of show you that this is a new thing that we're doing. So we're here. I have to solve for k, and the way in which I'm going to solve for k, oops, let me grab this, there, bring this up here. All right, so I now need to factorize. So I'm going to times this number, 2 by 27, and that's going to give me, so I need two numbers that when I times them together, I'm going to get negative 54. And when I plus them together, I get my middle term, which is negative 3. The first two numbers that should leap to your mind when you see the 54 is 6 and 9. And this works here as well. And to get negative 3 out, my 9 is going to have to be negative. So now I could rewrite this as 2k squared. And instead of minus 3k, I could write plus 6k minus 9k, go back to black, minus 27. And remember, this is less than or equal to 0. I then could factorize, I could take out my common factor. Here it will be 2k, and I'm going to be left with k plus 3. I then could take out negative 3 here, and I'm going to be left with k, sorry. I'm going to take out a 9 here and be left with k plus 3. Let me just check that that's correct. 2k times k is 2k squared. This is going to be 6k minus 9k minus 27 is less than that. And we know it's correct because we have k plus 3 and k plus 3 here. I then am going to go here and going to be left with this. From here, I can identify what my intercepts of my graph will be. K is going to equal 9 on 2, or it will equal k equals negative 3. So I could come over here now, and I could say, well, it's either going to be negative 3 or 9 on 2. I then am going to graph that. Let me graph it in red. So that is what it's going to look like. And remember, I'm trying to find these values of k for which my output is going to be less than or equal to 0. So when I put them in, I would need a result that is less than or equal to 0. So in other words, it has to exist below my x-axis. So I'm going to be looking here. So I have plenty of room now. So my final answer will be that my x will be equivalent to negative 3 to 9 on 2. Let me just double check that's the answer, and it is the answer. So my x will be negative 3, 9 on 2. It's going to exist between here in order that I have real roots. So that again was quite a journey, and I'm going to stop there, and hopefully this video helps you on your journey answering all these questions.